Hello, hello. Welcome to another edition of AP Stats Review Sheet. This is going to be a key, and let's hop to it. So, first few questions are FRQs, just to get in the rhythm of making our hypothesis test, making our confidence intervals. So let's read through it. Some boxes of a certain brand of breakfast cereal include a voucher for a free video rental inside the box. The company that makes cereal claims that a voucher can be found in 20% of the boxes. That's their claim. However, based on their experience with eating this cereal at home, a group of students believes that the proportion of boxes with vouchers is less than 20%. So they believe that it's less than 20%. This group of students purchased 65 boxes of the cereal to investigate the company's claim. The students found a total of 11 vouchers for free video rentals in the 65 boxes. Suppose it's reasonable to assume that the 65 boxes purchased by the students are a random sample of all boxes of this cereal. Based on this sample, is there support for the students' belief that the proportion of boxes with vouchers is less than 20%? Provide statistical evidence to support your answer. So like we talked about in class, when it says provide statistical evidence to support your answer, almost always is going to mean use a hypothesis test. I wanted you to do the hypothesis test and then a confidence interval so you can see how they relate to each other and get practice with both. All right, I'm going to do our hypothesis test first. That's going to start with our hypotheses. So you always need a null hypothesis and an alternative hypothesis. There is only one sample here. So this is going to be a one sample test, which means we are only going to have one P in our hypotheses, and it's going to relate to the 20%, not to another proportion. So our null hypothesis is going to be what's not interesting, that the company claims it's 20% and it is 20%. So we're going to say that P equals 0.2. Quick note, hypotheses never have hats, never. The alternative then is what the students think. And so some of you were asking, how do I know whether it's a less than or a greater than or a not equal to? The students think that it's less than 20%, that it's less than 0.2. That is our alternative hypothesis, that it's less than 0.2. And so this is going to inform our alternative hypothesis and then how many tails our test has, etc. The other thing I'm going to do here is set a significance level. It wasn't given to us, which likely means it will fail to reject or reject the hypothesis at any level, but you got to have some something to base your decision on, some significance level. So I'm going to set the significance level equal to 0.05. Okay. Hypothesis. Next, we're going to check our preconditions. Okay. We've been calling them random, small enough, and big enough. Okay. So the random and the small enough is about independence, and then the big enough is about normality. So that's why we check those three. It states that the 65 boxes purchased can be seen as a random sample. So we're just going to write that the problem states. Random sample. Small enough This is about being less than 10% of the population. So we can reasonably assume that 65 boxes, and notice it's about the sample size, not about the 11 vouchers that were found. It's the total sample size. So we can reasonably assume that 65 boxes is less than 10% of all boxes of this cereal produced by this company. Produced by this company. Okay, so theirs are small enough. So again, that's about less than 10% of the population, which in this case is boxes of cereal produced by this company. Last up, we have our big enough, and this is always about the expected proportion. So the expected, or what the company claims, is that 20% of the boxes have a voucher. So we are testing our big enough sample size of 65 times that 0.2, and then our sample size of 65 times that 0.8. Both of those need to be greater than 10 to satisfy our big enough. So this is going to be 13. This is going to be 52. So we are expecting 13 vouchers there's 13 boxes with vouchers and 52 without, both of which are greater than 10. Okay. So we've checked our conditions. Now we're going to dive into our formulas. So for formulas, this is where I'm going to name the test. And so you can either call it a one sample Z test for proportions, or a one prop Z test. So there's our name. We also want to show that our standardized test statistic, our Z-score here, that Z is equal to our actual proportion, which is 11 over 65, and you can put that in as a decimal, minus the expected proportion, which was 0.2, all over the standard error. This is going to be about the standard error we expect for 65 boxes if the proportion is 0.2. So this is going to be 0.2 times 1 minus 0.2 all over 65. And ultimately, what we're looking for is the probability that Z is less than this value. And I am going to cheat and copy and paste that. Because if we think about our normal curve, and we want to because we check the conditions for normal, if the actual proportion of boxes produced by this company that have vouchers is 20%, 11 over 65 is something a little less than that. Let's actually calculate that finally. 11 over 65 is like 17-ish%. So what we're trying to figure out is 17% here, which is, below what we expect, but not crazy amounts. This is a lot of area here. There's a good chance of getting something as extreme as 17. Or based on our sample size, based on how far we are from the predicted, is 17 putting us somewhere over here? In which case, this has a lot smaller chance of happening, and then maybe something interesting is going on. So that's what a p-value is giving us. It's always giving us a probability if the null hypothesis is true. And I'm going to put question marks on these 17s because we're not really sure where it's going to fall. All right, we ran out of room. Shocking no one. So we're going to shrink all this down and make some space. All right, so those are our hypotheses. We've got our preconditions. Here are our formulas. All right. Then we're to our calculation point. So for calculations, I'm going to put this into my calculator. You are more than welcome to do it this way and then use normal CDF if that makes more sense to you. It will work either way. I prefer to put things straight into my calculator because it just provides fewer opportunities for me to make silly algebraic errors. So I'm going to go to stat, tests, and then this is a one prop z test. So I'm just going to write that again, one prop z test. And if you're doing this, be sure to write down what you're putting in your calculator and label it. So P naught x n and then prop. So our P naught, our null proportion, is 0.2. That's what we're expecting. Our x is 11. This is the number of successes we actually found. And we found those 11 successes in 65 boxes. And this is the expected or assumed proportion. And is always our sample size. And then this, it gives you the options of not equal to P naught, greater than P naught, or less than P naught. Or excuse me, in the order it shows you it's not equal, less than, or greater than. So this should match your alternative hypothesis. Our alternative hypothesis is that the proportion is actually less than, that's what the students think, is that it's actually less than 20% of boxes with these vouchers. So our alternative hypothesis in the calculation is going to match that. So we're going to say we're thinking that it's less than the assumed. And so this is our alternative hypothesis. Okay. So let me actually put that in. Now, 65 isn't a huge sample size. So that's something to just take note of. It's big enough, but it's not humongous. When we calculate that, we get a z-score of negative 0.62. Even without a p-value, I hope by now you recognize that's still pretty close to the mean. That is a little bit below, which makes sense. We got 17%, not 20, so it makes sense that it's negative. But we're still pretty close to the mean in terms of the number of standard errors. And so that matches then with a pretty high p-value. The p-value in this case is 0.268. I'm just rounding. So that means we are, thinking back to our curve, we are more in this position than in that position. So I'm actually going to take this out. Okay. Because 26.8, if you think about that as a chance of something, that's like 1 in 4, a little better than a 1 in 4 chance of something happening. So what we're saying with this p-value is if the proportion of boxes with vouchers is 20%, like the company says, the chance of getting 11 vouchers out of 65 sampled boxes, or fewer than 11 vouchers out of 65 sampled boxes, is about 26.8, 27%. That's a pretty high chance. Okay. So, I'm going to shrink that down. After we've got 4 of our 5 steps, we've got hypotheses, preconditions, formulas, calculations, and now last but not least, conclusions. And this is the one where you have to be extremely careful. So use that first sentence stem. In this case, our p-value is greater than our alpha level. So we're going to say, because our p-value is greater than our alpha of 0.05 is greater than our significance level of 0.05, we fail. Those things go together. If it's greater, we fail to reject the null hypothesis. So that's our sentence 1. Second sentence is, we do not have convincing evidence that, and this you want to state exactly as your alternative hypothesis states it. If there's further conclusions or questions to be answered based on this, fine. But in your conclusion, you want to be very specific to reference the alternative hypothesis only. We do not have convincing evidence that the proportion of boxes with vouchers is less than 0.2. And so we're going to write it exactly that way. We do not have convincing evidence that the proportion of boxes that have vouchers is less than 0.2. That is our full, complete hypothesis test. Okay. So, in terms of answering the question based on our hypothesis test, is there support for the student's belief? So we want to make sure we answer the question, and I would say based on our hypothesis test, we don't have evidence to support the student's belief. Right, so there's the actual answer to the question being asked. Okay, so hypothesis test. Now, on the right side, I'm going to show basically the same thing, but with a confidence interval, and then you'll see how the conclusions relate to each other. So way at the top here, if we do a confidence interval, there's 4 steps on this one, and we start with the preconditions. Conditions. And for this, we have checked the preconditions already. So I'm just going to say same as for hypothesis test. If we didn't have this assumed 20%, then we could also just say, well, 11 is more than 10 and 54 is more than 10 successes and failures. So if we didn't have that 20%, we could use it. I'm also going to say we're going to do a 95% confidence interval because 95%, 5%, right? This is essentially both saying we're willing to accept a 5% chance of making the wrong conclusion of a type 1 error. Okay, so preconditions, same as for hypothesis test. Random, small enough, big enough. Next, we've got our formulas. Formula. So we want to name this. This is going to be a one sample interval for a proportion. Or a one prop z interval. The formula for this is basically the generic interval formula. So our p hat is going to be the starting point of our interval. It's going to be the center of our interval. And then we're going to add or subtract our margin of error. Margin of error is the critical value times the standard error of our sample. This you can find in words on your formula sheet. This is just a simple what you got out of how many. This is something that for 95%, you probably are already thinking 1.96. If you're not, pop that into your brain. There are ways to calculate it if it's not 95% or 90% or 99, but we'll get into that. For now, it's mostly going to be 95%. And then the standard error is basically the standard deviation based on our sample. So our p hat here is 11 over 65. So 11 over 65, which ends up being 0.169. And that was just our 11 out of 65. Plus or minus z star is going to be 1.96 for a 95% confidence interval. And then our standard error, it's basically going to be this, but with our 0.169. So we've got 0.169 times 1 minus 0.169 all over, and then 65 again because that's our sample size. So just a quick note in our different formulas. When we're doing a confidence interval, generally we don't have an accepted population proportion. So we're using our p hats in our standard error calculation. When we have a hypothesis test, we do have an assumed proportion or an expected proportion. And so for our standard error, that's what we're going to use in here, not our p hats. Okay, so once again, I'm going to not do this by hand. I'm going to pop this into my calculator to get my interval. And stat tests, and then this is a one prop z interval. It's 11 out of 65. And then our C level is our confidence level of 95%. And we get an interval of 0.078 to 0.260. Okay. So then for our conclusion, again, this is a sentence stem. You want to do this in a very specific way. You would say, We are 95% confident that the interval 0.078 to 0.260 contains the proportion of cereal boxes that have a voucher, or cereal boxes made by this company that have a voucher. Okay. In terms of answering the question, what's important here is this interval contains what the company said the proportion was. It contains the 0.2. This is about 7% to about 26%. So because that 20% is somewhere in the middle, to answer the question, we could say because our interval, or our 95% confidence interval, contains 0.2, we don't have evidence that the proportion of boxes with vouchers isn't 20%. And so therefore we don't have evidence to support the student's belief. So this is kind of the comparison of performing an inference or using inference to answer a question in a hypothesis test style or a confidence interval style. The hypothesis test is going to give you the probability of getting a result as extreme or more than the one you got in your sample. The confidence interval is going to give you the whatever percent confidence range of values based on your sample. So in that case, if the stated value, in this case 20%, is contained in the interval, that's kind of like failing to reject, right? We have the number that we thought it might be in the interval, so we don't have any evidence that it's not that. All right, I'm going to pause there. Hope this was helpful, and I will be adding more videos as the day goes on.